Question 1 from the 2018 Advanced Higher Physics Examination. Energy is stored in a clockwork toy car by winding up an internal spring using a key. The car is shown in figure 1a. The car is released on a horizontal surface and moves forward in a straight line. It eventually comes to rest. The velocity v of the car at time t after its release is given by the relationship v equals 0.0071 t. Take away 0.00025 t squared, where v is measured in metres per second and t is measured in seconds. And for 3 marks using the calculus methods, we have to determine the acceleration of the car 20 seconds after its release. Well, calculus methods tells us this, that the acceleration of an object is equal to the rate of change of its velocity. So if we know the velocity function, we can find the derivative of that function with respect to t, and we have the acceleration. So in this case we have v is going to equal to 0.0071, and there's the t there. Take away 0.00025 and t squared. So the acceleration will be dv by dt, that's the rate of change of velocity with respect to time. So all we have to do is find the derivative of that right hand side. So the first part, we're going to have the derivative to become 0.71 because the derivative of t is just simply 1. The second part, we have to multiply the number in front by 2 and subtract 1 from the power of t. So we're going to have 0.00050 t when we have the derivative of it. So now we have an expression for the acceleration of that particular toy car. And we'll write it as acceleration as a function of t is going to equal to 0.0071. Take away 0.00050 t. So all we have to do is plug in the value of t equal to 20 seconds, and we have the value for that acceleration 20 seconds after its release. So the acceleration at 20.0 seconds would be equal to 0.0071 subtract, and we'll put this in a bracket, 0.00050 times the 20 seconds. Now be very careful in your calculator, because we work out the acceleration, we get an answer of minus 0.0029, and the units are metres per second to the minus 2. So that's how you work out the acceleration from calculus methods. Part B. Determine the distance travelled by the car 20 seconds after its release. Well, we know the formula for the velocity is going to be equal to 0.0071 t minus 0.00025 t squared. And we're going to assume that the car is moving in the x direction, because if that's the case, then the velocity using calculus methods is just really equal to the rate of change of distance gone, or rate of change of displacement. So we can write down the following using calculus methods. We can say that the velocity v, if it's going in the x direction, is just really equal to dx by dt. That's all that really means by calculus methods. The velocity is the rate of change of the distance travelled in a given time, dx by dt. So if we write down what dx by dt is equal to, it's got to be equal to that formula above, which I'll write out like that, 0.0071 t, take away 0.00025, and it's going to be t squared. So we do a wee bit of manipulation here. We can say dx is going to equal to, put a bracket around that, 0.0071 t, take away 0.000, and write it out like that, and multiply by dt. So to find the distance travelled after 20 seconds, we have to integrate up. So to integrate dx, we're going to end up with the value of x, which is the distance gone after 20 seconds, and our integral will be the integral of this function here, from 0 up to 20. It's a definite integral. Put this in brackets, and there we have our expression, which we have to integrate. It's a big long expression, but it's actually not bad to do. So that's all we have to do. integrate this expression. So if I say x is going to equal to, I'll put the big square bracket here and integrate up. So the integration of this part here is going to give us 0.0071. We have a t squared, we've increased the power by 1. I'm going to divide by the new power. Take away the integration of this part here, 0.00025, it's going to be t cubed this time, divided by the new power 3. So there is the integral expression integrated, and it's from the limits of 0 to 20 seconds. Now the good thing about it is we know that when we do these limits, the second part of it's going to be 0 because we've got a t squared and a t cubed, so the second part is going to be 0. So all we're looking for is x is going to be equal to, plug in the number, and we'll put a big square bracket here, and we'll put 0.0071 all over 2 multiplied by 20 squared. So that's that first bit there. Take away the 0.00025 over 3, and the t cubed part is going to be multiplied by 20 cubed. Put that in that bracket there. And we're going to take away, well, you use the same expression again, but t squared and t cubed is going to render that 0. So it's going to be take away 0. So all we have to do is just work out that expression with our calculator. You take your time, you work your way through it, and we should have an answer of 0.75 meters. And that's going to be the distance travelled after 20 seconds.